Hi, good peoples. This video is going to be on linear functions, which is section or chapter 1.3 in your Pearson book. So we are going to identify some linear functions. We're going to do some x and y intercepts. We're going to graph. We're going to find the rate of change, which is the same thing as the slope, and a couple of other things. Find the marginal revenue, find the linear revenue, cost, and profit functions. So first things first in this video, we want to determine if this is a function or not. So one way we determine if something is a function is if it can be written in the form of f of x equals to ax plus b, where a and b are both constants. So that also, we talked about it in class, but that also means y equals mx plus b. We're not going to get into the slope-intercept form, but it's very similar to something of that nature. We also talked about how I want to make sure that none of my variables have an exponent more than 1. So no exponent more than 1, okay, greater than 1, right? And then also we said that we do not want x, no variables, right, in the denominator. All right, I'm writing bad right now. Okay, so for our first example, if I was to try to put this into some type of slope-intercept form, or if I was to put it in this form right here, let's say I hypothetically would solve for s. So I would add an s to both sides, and then this will give me s equals to 3t plus 5. Okay, so this is a variable equals to 3t plus 5. That looks very similar to the slope-intercept form. Now, this one asks us, if so, give the domain and the range. Well, this is a linear function. So linear functions should have a domain of negative infinity to infinity. Okay, and the range for linear functions are technically as well from negative infinity to infinity. Okay. Now, this one right here is just y equals to 9. This is technically a horizontal line across at y equals to 9. So this is in the same form of ax plus b. It just has the plus b. It doesn't have the ax there. So this is a linear function. So yes, linear. All right. So since this is a linear function, right, my domain, right, would be from negative infinity to infinity, and my range, as I stated previously, would be from negative infinity to infinity. Okay. Now my next question, C, I have x, y equals to 5. So that means I need to solve for y. If I was to solve for y, I would divide x by both sides, and y would equal to 5 divided by x. 5 divided by x is my rule number 3, where I have no variable in the denominator, right? So I have a variable down here in the denominator, so this is not linear. All right? Now, when we talk about nonlinear functions, we have a couple of rules when it comes to the actual domain and range. All right? I'm just going to go over the domain really quickly. But the domain would be all values except for 0. Okay, now why would I put 0? Because any time I have 0 in the denominator, that makes it undefined. So the way I write it in, so I can say all values except 0. But the way I write it in interval notation, right, would be from negative infinity to 0, union 0 to infinity. Now we can discuss about that kind of a little later of how we get into the nitty gritty of that, but that'll be a little bit later on in our semester. All right. Our next objective is to find intercepts. So in your book, it gives you this nice long definition to find the y-intercept, graph the y equals f of x, and then set x equal to 0, and then solve for y. So what I'm going to tell you is what you need to know when you're trying to find the y-intercept, right? Then you set x equal to 0 and you solve for y. All right. And then whatever you end up with as your answer, your y-intercept is written as 0b. Okay. When you want to find the x-intercept, all right, then, all right, you will set y equal to 0, and you will set y equal to 0 and solve for x. I'm sorry. And then your point will be just simply a0. So let's do an example really quickly, shall we? So here we go. To find the x-intercept and the y-intercept of 4x minus 8 equals to 16 algebraically, and first, if I want to find this x-intercept, right, I want to find x-intercept first. So to find x-intercept first, I am going to say, I'm going to set y equal to 0. So this should be 4x minus 8 times 0 equals to 16. Once I've done that, then I need to say 8 times 0 is 0, so 4x equals to 16. Divide both sides by 4, and x equals to 4. So my x-intercept should be 4, 0. Now I need to find my y-intercept. So if I find my y-intercept, all right, I set x equals to 0. So this should be 4 times 0 minus 8y equals to 16. So 4 times 0 is 0, so negative 8y equals to 16. The best way to solve for that is now divide both sides by negative 8, and y would equal to negative 3. Ooh, Jesus. I said 3. Negative 2. All right. So my y-intercept will be negative 2, 0. And now I found my x and y intercepts. So let's do an application, because as I've talked before, all of this is what? It is a little bit of algebra, and the rest is how you can interpret the information. So we have a business property is purchased with a promise of a payoff of 60 grand loan plus the 16,500 interest on the loan, making 60 monthly payments of $1,075. The amount of money Y remaining to be paid for the 76,500. You see what they did there? The loan plus interest is reduced by $1,275 each month. Although the amount of the money remaining to be paid changes every month, it can be modeled by a linear function. Y equals to 76,500 minus 1275x, where x is the number of monthly payments made. We recognize that integer values from 0 to 60 apply to this application. So the first question asks us to find the x and y intercepts of the graph, right? So that seems like a lot, but it's really not. So if I need to find the x and y intercepts, all right, so for the x-intercept, I am going to plug in 0 for y and solve for x. So in this case, give myself a little extra space here. So sorry. So in this case, if I plug in 0 for y, so that would be 0 equals to 76,500 minus 1275x. Because I plugged in 0 for y and solving for x. So we would subtract the 76,500. So subtract that from both sides, and we equal to a negative 1275x. In order to solve, we would now divide both sides by negative 1275 on both sides. And now we have to see how much does that calculate to. So if we do our quick calculations, we have 7,600 divided by 1275, and we end up with 60. So x equals to 60. Okay, so my x-intercept would be 60. 60. All right, that's my x-intercept. Now I need to find my y-intercept. So for the y-intercept, we do the same thing, except for we plug in 0 for x. So y equals to 76,500 minus 1275 times 0. So y equals to 76,500, and then that's it. Because 1275 times 0 is 0, and then you just add it with that. So what can I interpret from the intercepts? So what can I interpret? Well, I can say that the loan, the x-intercept corresponds to the number of months that must be paid. Paid. So, at $0. So therefore, I can interpret that the loan is paid off in 60 months, right? So the x-intercept is interpreting that the loan is paid off in 60 months. Okay. All right. And then let's see, how would I interpret the y-intercept? So I can say the y-intercept, if we re-look at it again, the y-intercept corresponds to the total loan that must be repaid after 0 months after purchase. So we can say that a total of 76,500 must be repaid. And that's the interpretation that I would get. Okay. How should x and y be limited in this model so they can make sense in this application? Since we know that the time that we pay is 60 months and the value of the larger is 60 will result in a negative value. This makes no sense in this application. So the values of x vary from 0 to 60, and that would be my input, but the output is the total number of owed at any time during the loan. So values for y can vary from 0 to 176,500. So it doesn't make total sense for the application, but gotta pause. I'm in my okay. My apologies. So if we move on to D. D, it says use the intercepts and the results of part C to sketch the given equation, right? So what information do we know? We know our x and y intercepts, right? Our x-intercept is 60, 0, and our y-intercept, I put it as y equals, but it should really be 76, and 0, right? So if I create myself a nice little quick chart, my quick chart would be my quick chart would be something like this. We could say 20, 40, 60, and then this goes to 76,000. So let's say 40,000, and then 80,000. Just trying to keep it simple. So boom, 76, boom, and that would be my line. All right. So this is part 1 video for 1.3.